All right, we'll kick it off now. We've given it a minute or so since the webinar start time. Firstly, I'd like to welcome everyone and thanks for joining Pluralsight for a webinar focusing on AWS and DevOps. I'm Jo Lanzaroni, the Marketing Director for Pluralsight in APAC, and I'm really excited and looking forward to hosting Wes and understanding a bit more about DevOps. Today, I just wanted to go through a little bit of housekeeping, which is how to actually engage in the webinar. There's a Q&A function at the bottom right-hand corner. If you'd like to register your questions in there, we'll be able to respond to those at the end of Wes's presentation. And also if you could include your email address so that we can ensure that we can get back to you in case we can't answer all those questions. We also will be doing a poll halfway through, so watch out for that. So the first 3 people to respond to that poll will also get a prize, albeit that prize might be a little bit delayed in getting to you because we're not currently in the office at the moment. As you can see, we're all working from home. Also, I wanted to thank you for giving up your time. We understand that time is precious and everyone's day is taken up with lots of commitments. So thank you for sharing your time with Pluralsight. So let's get started. I'm excited to introduce Wes Novack. Wes is an architect and engineer specializing in public cloud systems and web scale SaaS operations. He designs, builds and manages systems that enable highly available infrastructure, continuous delivery pipelines and rapid releases in large polyglot microservice ecosystems hosted on AWS and Google Cloud. Wes uses a variety of languages, frameworks, and tooling to define infrastructure as code, drive automation, and eliminate toil. Wes is a regular presenter and vocal tech community member and participates in various conferences and workshops. We're very lucky Wes is a Pluralsight author and an advocate for CALMs of DevOps, and CALMs stands for Culture, Automation, Lean, Measurement, and Sharing. Thanks, Wes, for joining us today, and we look forward to hearing from your presentation.
Thank you, Jo, very much. I appreciate the introduction. So as Jo mentioned, I will be hosting this webinar today. I wanted to also mention that if you want to get in touch with me after this, the easiest way to do that is via Twitter, and I am at Wesley Tech on Twitter. So let's get started. We're going to be talking about DevOps on AWS, and what we have to start that out with talking a little bit about what DevOps is. So if you asked 3 different organizations what DevOps is, they'd probably give you 3 different answers. But we do know that continuous delivery is an important part of DevOps. So what is continuous delivery? It's all about automated deployments, making delivering code repeatable and safer, which allows for smaller change sizes and smaller change sets to be deployed. This allows teams to deploy more frequently, and it also gives teams the chance to have faster feedback loops. In turn, teams are able to learn and react quicker. So if you're deploying something and you hypothesize that it would have a certain effect, then you can measure and respond and maybe do a follow-up deployment when you've learned from that deployment. Also, in times when you have an issue and you have to troubleshoot a problem, having a smaller change size allows you to more quickly determine the cause of that issue and correct it. But ultimately, continuous delivery is all about delivering more value to your end users and your customers. So what does AWS provide for continuous delivery? Well, they have a suite of tools that they call the AWS Developer Tools. That is what they call their tools now. In the past, they have called this umbrella of tools and services other names. And so if you're looking at AWS documentation, or maybe you're watching some old videos and old presentations, you may see these tools referred to as AWS Continuous Delivery Tools, or AWS Code Suite, or perhaps even Code Star. And that's not to be confused with the AWS service that's actually named Code Star. Before they had a service named Code Star, they would actually refer to this umbrella of tools as Code Star. So you can disregard all of those except for AWS Developer Tools, which is now the current name. But if you hear the tools referred to with these other names in documentation or in other videos, you know they're really just referencing the AWS Developer Tools set of services. So the tools we're going to focus on today are AWS CodeDeploy, which helps with deployments, AWS CodeBuild, which is the continuous integration and build service, and AWS Code Pipeline. There are other tools that AWS offers within their AWS Developer Tools suite. One of those is AWS Code Commit, which is a Git repository hosting service, but we will not be covering that service or other services today, just these three. So what are the benefits of AWS CodeDeploy? Well, it allows you to automate your deployments. It's a fully managed serverless service. So you don't have to stand up your own host. You don't need an EC2 instance to run the CodeDeploy service. AWS runs all of that for you. It's completely free within AWS. So you can basically leverage CodeDeploy for unlimited number of deployments within Amazon Web Services without paying a dime. And if you need to leverage CodeDeploy to deploy outside of AWS to target an on-premises instance in a data center, then you would pay 2 cents per on-premises instance update. Another benefit is the centralization of control of all of your deployments. If your team or your department or your organization moves all of your deployments to AWS CodeDeploy, you'll have this single centralized service to view all of your deployments and to control who has access to them. CodeDeploy is also very versatile. You can use it for deploying to EC2 instances. You can deploy to hosts outside of AWS, as I mentioned earlier. You can also use CodeDeploy to deploy to AWS Lambda or AWS ECS, which is Elastic Container Service. So what are the components of CodeDeploy? Well, the application is the core component. So you have to define a CodeDeploy application before you do anything else. After you have your application defined, then you can create a deployment group. And a deployment group is going to be a target for your deployment. So a deployment group typically gets named after an environment like staging, testing, QA, or production. And then, of course, you have the deployments themselves, which is used to roll out a revision of your application to the targets in your deployment group. Okay, so when you are rolling out a revision to your targets, how does CodeDeploy know what to do? Well, you specify all of the actions that need to occur inside of this appspec.yaml file. So the appspec.yaml file typically lives at the root of the code repository of the code that's going to be deployed, and it's a YAML formatted file. And I'm going to show an example of some of the keys that you would need to define in this appspec file here. So you're going to want to use version 0.0 unless they update the capabilities of CodeDeploy, and then you might use a newer version. You can specify an OS of Linux or Windows, and then you're going to use the files key to specify the source of the files that you want to deploy. And in this case, I'm specifying a source of /src so that CodeDeploy knows to take all of the files within the src directory of the code repository and then deploy them to the destination of /var/www/html on the EC2 instances that we're targeting. Then you have to specify the hooks. So CodeDeploy has this concept of lifecycle event hooks. There's a variety of event hooks available in the CodeDeploy service. Here you can see I've specified the before install event hook. If you want to know about all of the different lifecycle event hooks, please consult the CodeDeploy documentation. In this case, I'm telling AWS CodeDeploy to execute a shell script that is located in scripts/before_install.sh inside my code repository during this before install lifecycle event hook phase. I've got a timeout of 300 seconds and it's running as root. So we mentioned that CodeDeploy is a serverless service, and that's true. You don't have to stand up a master or a controller or a control plane. AWS handles all of that for you. But if you are targeting EC2 instances or on-premises instances, you have to install the CodeDeploy agent. So here on this slide, I'm demonstrating how to install the CodeDeploy agent on a Red Hat Linux-based system. And it's pretty simple. You would first specify your bash shell, and then you're going to have to install your Ruby prerequisite, which the CodeDeploy agent requires. And then you're going to, in my example here, I'm going to change directory into the /opt directory, and then I'm using the curl command to download the CodeDeploy install script from an S3 bucket that the Amazon CodeDeploy team maintains. So in this particular example here, you can see the endpoint is a S3 bucket located in the US-East-1 region, but the CodeDeploy team maintains this install script and the binaries for CodeDeploy in virtually all of the different AWS regions. So if you're going to be using this in a different region, you'll probably want to update this endpoint using the region code that your EC2 instances live in so that you get a faster download of that install script. After downloading, we're going to chmod the install script to make it executable, and then we're going to call that install script with auto as the first positional parameter so that the script will automatically detect what OS we're running and do the appropriate install of the CodeDeploy agent. All right, so let's connect all the pieces together of CodeDeploy. We've got the CodeDeploy service on the screen here that is shown as this rectangular dotted line box. For CodeDeploy to be able to do everything it needs to do, you're going to have to specify an IAM role, and that's Identity and Access Management role, and that's going to give CodeDeploy the permissions to do the things that it needs to do with the AWS services and objects that live inside your AWS account. So once you kick off a deployment, the CodeDeploy service is going to make a call to the CodeDeploy agent that is running on your EC2 instances. And then your EC2 instances is also going to have an IAM role defined on it so that it can reach out to appropriate resources like S3 buckets. And then as part of your deployment process, you're going to download an application revision from either GitHub or S3 or another source to your EC2 instance so that the CodeDeploy agent can execute that deployment process that was defined in your appspec.yaml file. The CodeDeploy service also can provide elastic load balancer orchestration so that you have, for example, if you have 3 web servers that you're targeting with your deployment that are behind a load balancer, the CodeDeploy service can remove one of those web servers from the load balancer pool or the target group one at a time to do the deployment, check the health of that application, and then add them back into the ELB load balancer pool or target group in a rolling deployment fashion so that you can do your deployment without impacting your end users or providing any downtime. Okay, so let's switch gears here from CodeDeploy to talk about CodeBuild. So CodeBuild is AWS's continuous integration and build service. So it's a fully managed build service. So much like CodeDeploy, there's no master server or anything else that you need to run or install anywhere. It runs fully in the cloud managed by AWS. It has elastic scaling, so you can run as many builds as you need concurrently across many different teams, many different applications without running into issues with capacity. Now, you are going to have some limits set on your account. There are default service limits, but if you run into particular limits, it's as easy as opening a request with AWS support to ask them to increase your limits. But you're not going to run into issues like you might with Jenkins or with TeamCity, where you run out of capacity because you only have a certain number of workers or agents to run your builds, and so you always have this issue of builds queuing. With CodeBuild, with its elastic scaling, you can mostly get rid of that issue there. Another benefit of CodeBuild is that you only pay for the build time used on a per minute basis. So you can have lots and lots of different builds defined in AWS CodeBuild, lots of build projects, but if you don't actually ever trigger those builds, you're not going to pay for anything. You just pay for the build time used on a per minute basis, and your builds also specify what size of a build environment they need in terms of how much CPU and how much memory they used. So if you don't have a high requirement for a lot of CPU and a lot of memory, you can use these smaller build sizes. Or if you do have a higher need, you can specify the higher ones and maybe pay a little bit more per minute for access to more CPU and more memory. CodeBuild is also CLI and API driven, so you can use the AWS command line interface. You can define your build projects with AWS CloudFormation or Terraform, and this is very conducive to a modern DevOps practice. You can define builds as code. And similar to AWS CodeDeploy with your appspec.yaml defining your deployment process, CodeBuild has a buildspec.yaml file that you can use to define your builds as code. And we're going to talk about that in a minute as well. It has tightly knit AWS integrations, as you might expect. So CodeBuild integrates with many of the other AWS services to allow you to do everything you need to do within your build process. It's extensible, so you can do a lot of custom things with AWS CodeBuild. They provide a Jenkins plugin, so if you want to continue utilizing a Jenkins master, but run all the builds inside of a fully managed elastic scaling build service, you can do that. AWS provides a certain set of OS environments and runtimes that you can use with AWS CodeBuild. But if you have some custom requirements, maybe you've got some obscure languages or frameworks that aren't supported in CodeBuild's default runtimes, then you can actually package up your own Docker container image and provide that to CodeBuild to get a custom build environment that you've created on your own. So how is CodeBuild used in a CI/CD pipeline? Well, it can run builds, it can do static code analysis, it can compile code, it can run tests, it can publish artifacts, and it can send notifications. So it's got a wide range of capabilities as a continuous integration and build server. So let's talk about the components of CodeBuild. CodeBuild has a build project, and that's the definition of your project. You have to define those first, and then inside of your build project, you have builds and or build runs, which is an execution of your build project. So let's connect all the pieces together with CodeBuild. You've got your CodeBuild managed service. You've got your build projects defined within the CodeBuild service. You've got your builds, and your builds also can have IAM roles specified so that they can have access to other objects or services in your AWS account. When you execute a build run, it's going to download source code from a GitHub repository, an S3 bucket, or somewhere else. And then it's going to run all of the build steps that are codified in your buildspec.yaml file. And if everything passes, your build is successful, your test passes, then you might output an artifact and publish that to an artifact store, maybe to Artifactory or Nexus or Elastic Container Registry if you're working with Docker containers and images. Or maybe you just publish a zip file to an S3 bucket as your artifact. So we talked about the build spec file earlier, but we didn't look at the details of that, so let's do that now. It's a buildspec.yml file, typically lives at the root of your code repository. You're going to want to use version 0.2 because that allows all of the phases of the build to run in the same shell and execution environment. And then you're probably going to want to specify some environment variables to be available during your build processes. So if you got some plain text, non-secret environment variables that your build needs access to, you can specify those in this variables YAML key underneath that. But if you do have some secrets, such as a password or an API key or something else that should be kept secret, then you're going to need to use something else like EC2 Systems Manager Parameter Store or AWS Secrets Manager. And in the build spec file, you would specify the name of the environment variable as the key, as listed on the screen here. But for parameter store, instead of having the secret value specified right there in the buildspec.yaml file, you would actually specify the path to the parameter in AWS EC2 Systems Manager Parameter Store. So that's a good way to store and use secrets for free within AWS. Parameter store is free. Secrets Manager is a paid secret service in AWS. Each build spec file is also going to need to include this phases top level key and one or more subkeys for the different phases of your build process. So in this example, I've got a build phase defined, and then under that, I've got the commands that I want to run during that build phase, and I've just got some placeholder commands here for compile commands and maybe some test commands. And then if all of your phases of your build complete successfully, then you might have an artifacts key here as well, which will help you to publish an artifact. And in this case, I'm specifying a single jar file to publish as my artifact. All right, let's take a break there and see if anyone in the audience can remember one of the benefits of CodeDeploy. So this is something that Joe mentioned at the start of the webinar. If you can paste a benefit of CodeDeploy in the chat, then Joe is going to help you out by sending you some type of Pluralsight prize eventually.
There we go, we've got one. Serverless, no EC2 instant needed. Is that correct?
Yes.
From Anish. Anyone else?
All right, I'm going to keep going. If anyone else has any answers for that, different than the one that was already posted, please feel free to post those in the chat.
Great.
All right, switching gears to AWS Code Pipeline, which is the third service we're covering. So AWS Code Pipeline is a fully managed pipeline service. So Code Pipeline helps you define the full software delivery process. You pay only for the active pipelines in a given month. So you can have as many pipelines as you want defined, but if you don't actually have any executions of those pipelines, you won't pay for them. It has tightly knit AWS integrations, as you might expect. So inside of your Code Pipeline pipelines, you can call AWS CodeBuild, you can call AWS CodeDeploy, you can call AWS Lambda, lots of things you can do with Code Pipeline actions. It also has third-party developer tool actions. So if you need to define a load testing service or maybe a UI testing service as part of your pipeline, you can do that with the third-party developer tool actions that are available within Code Pipeline. And it's extensible via Lambda and custom actions. So I touched on this before. A Code Pipeline can have an action that calls an AWS Lambda function. So if you need some custom code and custom logic to be executed during your pipeline, you can easily do that with Lambda. And if you need to create your own custom action, you can do that as well. So what are the components of Code Pipeline? We've got pipelines, which are the definitions of software release processes. And we've got executions, which are the invocations of a defined pipeline. So pipeline components, we've got stages, which are a collection of action groups that contain actions. You've got transitions, which are the connections between the stages. And you've got artifacts, which are bundles of code produced by a stage and ingested by another stage. So let's take a look at what a pipeline stage might look like. So inside of a pipeline stage, you've got one or more action groups, and inside each action group, you've got one or more actions that are going to occur in that pipeline stage. Now, the action groups are actually more of a construct of the AWS Code Pipeline web UI. And the way that actions are grouped into action groups are by this configuration parameter called the run order. So 1 is the default run order, and that's the highest priority run order in terms of what will run first. And any actions with the same run order are going to be grouped into the same action group and run in parallel. So these two actions defined on the left here in the diagram that are green and purplish, those are going to run concurrently at the same time. But in the second action group, I've got two actions that are defined with run order 2, and those are going to wait to execute in my pipeline stage until the actions that have run order 1 have completed. When those actions in the first action group complete, then the actions in the second action group will kick off, and they will concurrently execute because they have the same run order. So let's visualize a code pipeline and some of the stages that you might have defined. So in this visualization, I've got a source stage. Inside the source stage, I've got an action group that calls a GitHub action to get the source code for an application and download it. And then the pipeline has a transition to the build stage. And the build stage is going to have an action group that calls a CodeBuild action. And maybe in that CodeBuild action, I'm going to compile some code. Maybe I'm going to do some static code analysis or linting. And then I'm going to run maybe some unit tests or some integration tests or some other tests. And then if that's all successful, the pipeline is going to move through another transition into the deploy stage. And then I'll have an action group defined that has a AWS CodeDeploy action, which might deploy this code out to a set of EC2 instances that are behind an elastic load balancer. But the pipeline depends upon each stage to be successful. So if, for example, in this pipeline, if one of my unit tests failed in this build stage, then the pipeline would stop at that transition between the build stage and the deploy stage, and a deployment wouldn't happen. So let's talk about the different action types in Code Pipeline. There are lots of action types, including a source action, a build action, a test action, deploy action, approval action, and an invoke action. So a wide variety of capabilities here. And again, you can also call AWS Lambda in your code pipelines to do some more custom logic that might not be supported out of the box. So I'm going to shift gears here really quickly and jump into the AWS console and look at AWS CodeDeploy. So remember, the first thing that you need to do in AWS CodeDeploy is to define a CodeDeploy application. And in this example here on my screen, I've got an application already defined called My Web App. So I'm going to click into the My Web App CodeDeploy application. It's going to take you to some details about this CodeDeploy application. Shows that it has a deployment group named Staging defined already, and that a deployment recently succeeded to that deployment group. If I click on this Deployments tab, I'm going to see a history of all of the deployments that occurred for this application. And you can see that I have 3 succeeded deployments and 1 failed deployments for this CodeDeploy application. So let's take you through doing a deployment really quickly. Before we do that, let's look at the web server that I've got. I've got 2 EC2 instances that are behind a classic ELB. And you can see here I've got a Global Mantics image logo, and then I've just got some text on a HTML page here. So if we wanted to update this web page, we can use CodeDeploy to deploy a new revision of the application out to the web servers behind this load balancer. So let's go back to the CodeDeploy console, click Create Deployment. I'm going to select the Staging Deployment Group. I'm going to select the radio button for GitHub that my application is stored there. For repository name, I'm going to grab that. from my GitHub repository. And then it requires that you specify the commit ID. Again, I'm going to jump back here to my GitHub window tab, grab a commit ID, paste that in here. And then there's a bunch of other optional check boxes and radio boxes that I'm going to ignore, and I'm going to click Create Deployment. So I'm targeting a version of my application and a specific commit version in that repo. If we scroll down here, as soon as you create that deployment and define it, it's going to kick off an execution of that deployment and try to deploy it. On the bottom here, you can see that we've got 2 EC2 instances identified as part of the deployment group that we're targeting here. And you can see that one of the EC2 instances is in progress and one of them is pending. And the reason it's only doing one instead of both of them at the same time is because we're using the deployment configuration of one at a time so that we don't cause an outage for our users as we're deploying this code. And if we click over here on the view events for the EC2 instance that's currently in progress, we can see the different life cycle events that are occurring as part of this deployment. And you can see that most of these have already succeeded, and we have 2 pending left. And we're actually in the process right now of adding the EC2 instance back into the load balancer and waiting for those health checks to show up as good before we proceed with the next event here and proceed to the next EC2 instance. So you can see here also that these deployment events, most of them show as less than 1 second, and that's because I had nothing defined for that lifecycle event hook in the appspec.yaml file, but some of them have a little higher time, like block traffic when we're doing ELB manipulation, or before install. This is where I specified my script, and it actually performs some action to deploy the new version of the code. So this EC2 instance, you can see all of the events now have completely succeeded. So if we go back to the deployment ID page for this deployment, you can see we've got one succeeded, and now the second instance is in progress. So if we click the view events on that second instance, you can see the code deployment as it rolls through the different events in the deployment process here. But since the first server already succeeded and completed its deployment and was added back into the load balancer, now we should be able to go back to our website, do a refresh, and we'll see an updated version of the text on this page. And it looks like I've got a little bit of a demo fail here because it is not updating. But we get the idea of how the deployment works and how we can view the CodeDeploy console to watch a deployment as it's rolled out to your target group and the instances behind your group, your deployment group. So with that, I'm going to jump back to the presentation, and I want to mention all of the excellent content that we have on Pluralsight around AWS. We have many, many different paths and courses. A path is a collection of courses in a specific topical area, and we have even more paths than are shown on this screen for AWS. And we have dozens and dozens of courses. We've got skill IQ tests for AWS. We've got role IQ tests for AWS roles. So there's really a huge amount of content in the AWS space that we cover on the Pluralsight skills platform. In addition, the content that I've been presenting on here today for the AWS Developer Tools and for getting started with DevOps on AWS, I've got my own course called DevOps on AWS Getting Started, and it goes into much more detail on CodeDeploy, CodeBuild, and CodePipeline. So if you want to get started and get some better knowledge on these services, I highly recommend you check out my course there. So with that, that brings us near the end of the webinar and to our Q&A section.
Just opening up the Q&A.
Thank you, Joe.
One question, is there any way to extend all these tools into a VMware on AWS environment. For example, could CodeDeploy talk with vCenter and provision a new VM and then automatically configure it to a domain controller in our domain? Thanks, Francesco.
So that's a good question. CodeDeploy is a bit limited in terms of its capabilities, and I don't believe that CodeDeploy can do what you were requesting there. However, there are some interesting things you can do with CodeBuild, because you can essentially run like arbitrary AWS CLI commands or other tools within your build process if you need to do some custom things. So you might be able to wire something up as part of a code pipeline using CodeBuild for that, but CodeDeploy itself probably couldn't do the provisioning of new VMs.
Okay, great. Thank you. Now there's one other question here as well too. How do you handle secrets and environment variables with CodeDeploy?
Yes, great question. So CodeDeploy actually doesn't have native support for deploying secrets. As you might recall from the slide presentation, CodeBuild has a section for integrating with EC2 Systems Manager Parameter Store and also AWS Secrets Manager, but CodeDeploy doesn't have that native integration. So what you're going to want to do with CodeDeploy to get secrets out as part of a deployment is to use the AWS CLI to make calls to either Systems Manager Parameter Store or AWS Secrets Manager to fetch a secret and then inject it into the target instance where you might be able to use it in your application, whether that be a config file or somewhere else.
Okay, great. And just looking at the Q&A again, there's one other question. Can you use these tools to deploy to Kubernetes?
That is similar to my answer around using CodeDeploy to manage VMware, in that CodeDeploy doesn't support natively deploying to Kubernetes, but you can use CodeBuild and custom, maybe a custom runtime with AWS CodeBuild. So for example, you might provide a custom Docker container image to CodeBuild to use in your build environment. And maybe you have kubectl inside of that container image so that you could facilitate deployments to a Kubernetes cluster.
Okay, great. Well, that's it for the questions that have come through from the Q&A section of this webinar. Wes, if anyone wants to respond to you on Twitter, can you repeat your Twitter handle again, please?
Yes, that is Wesley Tech.
Wesley Tech. Great, fantastic. Well, thank you, Wes, for sharing your knowledge on DevOps. And we really appreciate your time, and thank you for being a Pluralsight author. And again, thank you to all the participants who've logged on today. We really appreciate your time that you spent with Pluralsight. And if there's any other questions or further engagement you'd like with us, please reach out to either of us, Wes or Joe Lanzaroni, and we'll be sending you the recordings post this event as well too. Thank you.
Thanks, everybody.
Bye-bye.